Okay, it's live.
Okay, great. Students, welcome to the Hangout for Compiler Theory and Practice class. Hope you're all doing well. And the big announcements I would like to make first and make then take some questions. So the biggest announcement is this that we haven't really heard from many students, in fact, whether they would like to do the project part 2 in a group, a team of two, or by themselves. Chao is setting up a sign up sheet. Those who want to have a partner need to let us know by this weekend, by tomorrow or Sunday, and we will then randomly assign the students who are needing a partner. If you don't sign up, we are going to assume that you will be doing it by yourself. In any case, the project is due in a very short span of another month, and if you haven't really gotten started on it, it is really getting late. We will not be able to give any extensions because it's the end of the semester, and we cannot extend it beyond a certain date because of it will clash with the due date rules by institute. We are not allowed to make something due during the dead week, the study week, and so on. And so the deadline is pretty tight there. So please get started. And if you need any partner, then let us know and coordinate and get going this weekend. So that is my biggest announcement of the week. Again, our hands are tied in terms of we cannot extend the due date because of the institute rules on due date cannot be during the study week. So please get going on this, as I mentioned. The other thing is, I hope you're all pacing the things properly and reading the um, respective book chapters, not just watching the videos, because it's really important that um, we understand the material from the book. Um, Hope we are all doing the homework 3, which is due in a week, and reading the respective material. And let's see where we are in terms of our pacing schedule here. And uh, I'm going to go over that just in a minute. So, one of the things that we are going to do is, of course, the one last homework which will be given to you in early April, so it is a little bit far away. But we should be in the week uh, uh, number 10 here, which is P3L2, and reading the chapter 13 and understanding the things which will be also important for the project and so on. So, in terms of pacing, um, that's where we are. And I hope all of you are understanding these topics. If you are facing any problems, let us know. You should go through the examples. You should try to understand the techniques, work out some things by yourself, and also try the homework problems, which will give you a good understanding of the topics. Um, I guess in terms of chapter 13, which is the one which we are doing now, um, trying to look at this is about the register allocation, and this is an important topic. We're given homework on this, and graph coloring based register allocation is really important. It's a part of almost all production compilers, and so you will be also implementing this in your project um, part 2. So hopefully the practice through the homework and understanding will help you speed up the implementation. um, so that's an important topic. And before this, in P3L1, you should have finished the liveness analysis and things like that, which um, help you to find out the live ranges, the webs, build the interference graph, and so on. And then translate this into the uh, register allocation using this particular chapter 13. So those are the two related topics. So maybe sometime you might have to go back and forth between what you were covering in P3L2 and P3L1, because one feeds into the other. The liveness is the starting point. Hopefully the concept of live ranges is clear, and from there you will build the webs, which are the live ranges which share the use, because they have to remain in the same register. And from there you will build interference graph and do the graph coloring, which is in the chapter 13. Going forward, chapter 8, these are more about optimizations, which will help you figure out the other part of the homework. The last question is related to that in terms of how the optimizations reduce redundancies, local value numbering, super local value numbering, and so on. So that will help you get a good handle on it. But that is not related to these topics which I mentioned. And so read these register allocation topics together, paste them, do the homework, and try to get going in terms of the phase 2. You can start by doing, as I think last week I mentioned, that the way to get this done is to generate simple instructions for IR, for arithmetic, then conditionals, and then so on, cover all the different instructions, generate naive code, which means that you're loading and storing values at each point, and then design a register allocator in a sense that some of these values are held in registers, and you will change the names to the register names, and then plug it into the instructions so that your instructions operate with the registers, and introduce load stores only at the ends of the live ranges. And that's the way to get this code going for the last part of what we are asked in our project. So that's the way to follow it. And it is really, really getting late if you are not started on it. So get a teammate. And even if you don't have a teammate, you can get started on it, and then involve a teammate and do the work and split the work up. So that is my advice. And Chow, so that's about all. I have the announcements for today. Chow, do you have anything to add further, or any other announcements?
Yeah, I think in terms of the teaming information, I have shared a Google Doc with you guys through the Piazza. So just please fill that sheet, the document, to let me know about your teaming informations by this weekend. So, and then I will assign some of you if you don't have during the weekend. Yeah, that is all.
Great. Okay, so let's wait for any questions if there's anybody on the home. Are there any questions we need to visit on Piazza, or is there anybody here who has any questions?
There is no questions on Piazza.
Hi, Professor Entao. Sorry that I'm a little bit late.
Hi, how are you?
Yep, I'm good. Hi, Professor. So there's another question from Piazza. I'm not very sure about how to answer it. So it's about the initializing the floating list into the MIPS assembly code. So how to initialize a list of floating numbers?
Initialize?
Yep. Like if we want to initialize a list of floats of size 100 to
You mean
probably
initialize?
0.5. Yep.
You mean initialize a floating point array inside
Yep.
MIPS,
Yep.
inside the MIPS assembly? Actually, you need to. I think I will share some like the assembly code document for it. It just the MIPS assembly code has specific the keyword when they define an array or define a variable. So I think I'm not sure whether MIPS assembly has exactly the same thing with the x86, but if I remember it correctly, it's just a space. So it will space reserve some what is that? It's reserve the required number of elements, and let me check. Let me search for some assembly. Okay, just found this document.
So I guess you have to generate the data segment with the array name followed by dot word, and then just put the initialization values following that on that line. This is on the Stack Overflow answer.
Yeah.
I think that's one way. So, but if if it's a very long array, for example, 100, do we need to like put 100 such values there? Since I know for if it's just integer, we could use the colon to specify how many such numbers we want. Right? I can put it onto the chat.
I remember there is another keyword. I forgot it.
Yeah. So, for example, if it's an integer, we want to initialize 100 to 0. 100 zeros into this array. This is how they could do it. I'm not sure if there's such similar syntax for the floating point. I did some research online, but I didn't find an answer for that.
So this will not work for floating point, is it? The one which we just talked about? Like array name, colon, then the list of floating point numbers.
That will. Yeah, I can try it now, actually.
Yeah, can you check? Because it should typically work for any value, I think. Because I know it works for integers and also enumeration types.
Yep.
Probably should work for floating point also. Check on it, okay?
Okay, sure.
All right. Any other question or?
Yeah, I think we are good for other questions.
Okay. Okay, so since there are no other questions, I guess I'll mute and I'll be back in a few minutes.
Okay, it seems like MIPS doesn't have that specific directive.
Yep, it seems to be that way.
Hmm. Oh, it is. I find it.
Yep.
It is simply with my Google Hangout. Oh, you're right. You put what you posted right. So
But this is for like integers, right? I don't think it works for floating numbers.
no, no, you just need to replace the floating with the word to float.
Okay, I'm going to try that to see if that works.
Okay, since there is no more questions, let's just stop here.
Okay. Okay, bye.
Bye.